On the AP test, you are not going to be tested on if you can name compounds, but I do think it's good working knowledge in the chemistry lab that you can be a little bit familiar with these chemical names. So when you're naming a compound or a molecule, the first thing that you're going to look for is, does it have a metal? And you're going to use those oxidation numbers and your periodic table to help you. So remember the pattern across the periodic table: +1, +2, +3, +4, -3, -2, -1, 0. Most of the metals do have numerous oxidation numbers, and that's because most of the metals are transition metals, and they can have more than one oxidation number. So let's just dive in and do some practice with naming these compounds. So first of all, if it has a metal, then I'm going to use oxidation numbers. So I'm going to do this first one. This is copper. And then the second element, I'm going to drop the ending, the INE, and I'm going to put IDE. So that means that we have a chlorine that's now bonded to a copper. So this is copper chloride. Do the next one. This one is copper. Oh, and look, I have chlorine again. So this would be chloride. Now look at the names. They're both the same, but look at the formulas. So we have one that has only one chlorine and one that has two chlorines. So I have to use oxidation numbers. And I'm going to figure out copper's oxidation numbers. Chlorine, looking on the periodic table, is a halogen and it has an oxidation number of -1. So therefore, what does this copper have to be? Well, it's a +1. And I'm going to put the name right in the middle. So copper 1 chlorine, and this 1 has to do with what the copper's oxidation number is. And copper is a +1. Let's look at the next one. So I have another copper chloride, and this time I have two chlorines for a total of -2. So each of them has a -1 oxidation numbers. So that means this copper must have a +2 because it has to have two chlorines. And notice I use Roman numerals when I name them. So you can make them fancy with tops and bottoms, or in this one I just did two little dashes there. So I have copper 1 chloride and copper 2 chloride, and that's how I say it. And it just goes through the periodic table, looking up what chlorine is, it's a -1, and doing a little bit of math. It should always equal 0. So the metal plus the non-metal should equal 0. Let's do the next one. So potassium, and this is another chlorine. So drop the ending IDE. Now potassium is a group 1 metal, and it is always a +1. Because that, I don't have to tell people. So this is just potassium chloride. You wouldn't say potassium 1 chloride. That's because it's always a +1. So in general, you are going to put the oxidation number in unless it's a group 1A or 2A metal. Also, these elements here only have one oxidation number. Zinc is always a +2, cadmium is always a +2, aluminum is always a +3, silver is always a +1, and gallium is always a +3 also. So these don't need their oxidation number. And remember, I wanted you to memorize that diagonal series, the aluminum, zinc, silver. So this just goes and reinforces that they only have those oxidation numbers, and so you don't have to tell it in the name. Let's do some practice naming. So this first one, I see a metal, so that means I use oxidation numbers. So nickel, and it's oxygen, but you drop the ending and do IDE. And oxygenide sounds weird, but oxide sounds better. Oxygen on the periodic table is a -2. It's in the -2 column. That means this nickel must be a +2. So I just put a 2 there. Iron, bromide, and bromine is a -1, and I have 3 of them. So each of them are a -1 for a total of -3. That means this iron must be a +3. So I get 1, 2, 3. This next one is sodium. Now, if I see 3 elements, this is called a polyatomic ion. And this is the polyatomic ion nitrate, and you just put the name down. So NO3, and it has a charge of -1, this whole group. And sodium is always a +1. And because it's a group 1 metal, it's always a +1. You don't have to tell people because everybody knows it's a +1. So sodium nitrate. So your polyatomic ions are kind of easy if you know what the little grouping is. So if you see 3 elements, look up on your polyatomic ion sheet, that goldenrod sheet I gave you, and you can see what the name is. Let's do this next one. So iron 3. Oh, we're going opposite. So iron 3, so iron with a +3, nitrate, NO3 minus. So when I put this together, I want to put it together in a combination where they will cancel. If I just stick it together like this, a +3 and a -1, I'm going to end up with a charge of +2. So instead, I'm going to have 3 of these nitrates because then that will give me a -3 total. And I write that Fe NO3, and I'm going to put parentheses around the nitrate. You always want to keep it together and then say that we have 3 of them. So it looks kind of funny, 3 parentheses 3, but that is correct. Let's do the second column. Potassium nitrate. Potassium is a +1. Nitrate, we know what that is now, NO3 minus, and it looks like I can just stick it together. If you only have one of the polyatomic ions, you don't need the parentheses. So you wouldn't need to go like that. That's kind of overkill because there's only one of them. But you do want to put parentheses around it if there's only, if there's more than one. Cobalt is CO, and it's a +2. I know that because this always goes with the metal, and the oxygen is a -2. And look, a +2 and a -2, I can just put them together. But that is how you write these compounds, these ionic compounds. Now, if there's no metal in a compound, therefore we would call it a molecule. So this would be nonmetals bonded to nonmetals. You just tell how many you have of every single atom. So you name the cation and then you name the anion, adding IDE, and use a prefix to tell how many of each of them you have. And this should be down on your goldenrod reference sheet. You're going to use a prefix to tell how many you have. And so let's go ahead and start this. So very rarely do you say mono if you just have one of them. So this first one is nitrogen. So you just name it. And then the next one is oxide. Drop the ending IDE. And then we have to say how many we have. Well, I just have 1 and 1, so I'm just going to leave it. Nitrogen oxide. This next one is also a nitrogen oxide. But I need to say how many I have. So di means 2, so dinitrogen. And then 5, I would use penta. And say it out loud. Does pentoxide sound good or pentaoxide? I would take either way. I'm just going to leave it pentoxide. So from the name, you can write the formula. This is one of the ones that has the mono. So this is carbon monoxide. And this next one is carbon dioxide. And it's okay to guess on your homework and then look them up on Google. Just type in the formula and it'll tell you what the name is and you can see how you did. So the whole purpose of this goal is just to get some exposure and some practice and some guessing on what the name is. So please, please, please use the internet. Look up what the answer is. There's also, you can look up the answer key too to check. So this first one is sulfur and then dioxide. So I just use the prefixes to say how much I have. So this one would be hexa, sulfur, and it's dioxide. This one is carbon tetrafluoride. Tetra means 4. Oh, I said fluoride, but it's chloride, tetrachloride. And last but not least, diphosphorus octaoxide. Boy, that's a mouthful. So then there's your 8 and your 2. So if there are no metals, you don't have to use oxidation numbers. Oxidation numbers are only for compounds that have metals. Let's talk about naming acids. So this first one is binary acids. That means there's only 2 elements. You'll have hydrogen that is written first typically and then a nonmetal. And I just memorize HCl, and know that if there's only two elements, you just copy the name of HCl, which is hydrochloric acid. So again, there's the hydro and there's the ic, and in the middle is the root word for chlorine. This next one would be hydro, named just the same, bromic acid. And the next one is sulfuric. Sometimes saying out loud helps. Sulfic sounds weird. Hydrosulfic sounds weird. So hydrosulfuric. So I really had the whole name of the element there. So notice that they have the whole hydro and ic. So that's if you have only two elements. And again, you can see those H's are first. Ternary acids means that there's a polyatomic ion. And usually the polyatomic ion has oxygen in it. And it's named by the polyatomic ion. So look at the polyatomic ion. If the polyatomic ion ends in 8, then your ending of your acid will go to ic. If it ends in ite, then your acid will end in OUS. And this is kind of the rule here. So the most common form of that polyatomic ion, the parent, it will be just ic. And if you have one less oxygen, it turns to us. Two less oxygens will be hypo-us, and one more oxygen will be per ic. And if you look at the family, if I give you an example of acid in a family, the element right below it will have the same form. So for example, let's do this next one. So we have, and on these I'll always give you a clue. So HClO2, so this right here, this portion, this is chlorite ion. So what I'm going to do is I'm going to get rid of that ite, and ite turns to us. So this is chlorous acid. This whole polyatomic ion has a charge of +1, hydrogen's a plus, excuse me, the chlorite has a charge of -1, and hydrogen has a charge of +1, so they cancel out. Let's do this next one. So H2SO4, so this is sulfate ion, this part right here, has a charge of -2. So that's why I had to have two hydrogens to cancel that out. So I'm going to get rid of the 8, and I'm going to put ic. So this is, and sulfic sounds weird, so sulfuric acid is what that one is. Sulfuric acid and chlorous acid. So again, named after the polyatomic ion. So again, on these, use the polyatomic ion list, look it up, see if you can figure out the name, and go to the internet and just check. Type in the formula and see what name comes up, and see how you did. Elements in the same family are named similarly. So if perchloric acid is HClO4, then what's the name of this guy? This would be bromic acid. This one is sulfuric acid. Well, what if it's selenium as that middle? It'd be seleniic. Seleniic. Sure. Okay. Seleniic acid. Molecular empirical formulas. Empirical formulas are the smallest ratio. So the molecular formula is how many atoms there are. But if we looked at the smallest ratio, we would call that the empirical formula. So look at this first one, N2O4. That's, if I divided through by 2, I would get NO2. That would be its empirical formula, the lowest ratio. C8H16, I can divide by 8, and I get CH2. Look at this one. What can I divide by? And because this is a 1 to 1 to 3 to 1 to 2, I can't divide by anything. It's going to be the same. So sometimes the molecular formula and the empirical formula are the same. And that is the case anytime you have an ionic salt. It will always have its empirical formula as its compound formula. So you can stop the tape if you think you've got enough, but I'm just going to take you through some more naming examples. Let's do this one. This is calcium, which is in group 2, so I don't have to do the oxidation number, and then bromide. Calcium's always a +2, so you don't have to tell people. This one's nickel and oxide, and nickel's in those transition metals, so I better figure out what it is. and it's a +2. So oxygen on the periodic table is a -2, so that means this is nickel 2 oxide. This is cobalt iodide. Each iodine is a -1 for a total of -2, so that means the cobalt is a +2. So cobalt 2 iodide. This one is, look, no metals. So I don't use oxidation numbers. I use prefixes to say how many there are. So dioxygen, oxygen's first, so you just write the name out. You don't do the ide. Only the second one is ide. Fluoride. Oh, I'm spelling it right. Okay. I might have messed up that last one. It is a difluoride. I think I goofed and didn't put the di. This first one starts with H, so it's probably an acid, and it is. This is hydrochloric acid. This next one is calcium chloride. And you don't have to tell what the oxidation number is of the metal because it's always +2. This starts with a H, so it's an acid. This is sulfuric acid. This next one, sodium. Now look, there's 3 elements. There's sulfate. So it's a polyatomic ion. And you just name it. Sodium sulfate. You wouldn't say disodium because there's a metal. And if there's a metal, the sodium, you can't use the Greek prefix system. And this last one is aluminum nitrate. And aluminum is always a +3, so you don't have to tell people. Here's some more practice. If you feel like you've got this, then you can just fast forward this portion of the video. So this first compound, it does have a metal, barium. So I just write it. And barium is in group 2, so it's always a +2, so I don't have to tell people. And then I have chlorine, but drop the ending IDE, and I'm done. The next one, barium. Now I see the rest of it after barium, there's 2 elements. So this is a polyatomic ion, so just look it up. Carbonate. The next one is a metal, so I use oxidation numbers. Oxygen, drop the ending IDE. And I do need to say what the oxidation number is because it's not group 1 or 2. This is a transition metal. So oxygen's a -2, so that means manganese is a +2. So just write it in Roman numerals. Next one, titanium comes first. That is a metal. And I do have to put the oxidation number in because it's not a group 1 or 2 metal. Oxygen is still -2, and I have 2 of them. That's a total of all the oxygens is a -4, so that means the titanium has to be a +4, Roman numeral 4. Silver. Silver is a transition metal, but it's always a +1, so I don't have to tell people. And then oxygen, drop the ending IDE. And this last one, there's no metals at all. So I just say that I have 1 of these and 3 of these. So phosphorus trioxide. So just another look at the periodic table, which ones you do have to put the oxidation numbers in would be the ones in pink. So the majority, you do have to do those oxidation numbers. So only group 1 and 2, and then I think that you'll be good just for doing that series of 3. It should be fine. And then the blue ones here, these are non-metals, and remember they have their own naming system.